じゃあ、go to the today's part. It's okay? はい。じゃあ、go back to the today's part. メディカルロボットね。メディカルロボットは何ですか？メディカルロボットなんだけど、メディカルロボットは、ここにあるようにサージカルロボットと、サージカルロボット、テレメディスンというのと、ホスピタルのロボットと、リハビリテーションロボットがありますよと、ここには、まあ、some categorization. One of the categorization of medical robot is looks like this. ね、サージカルロボットは、オーペディック、オルフォペディック、ラパロスコピック、ニューロサージカルがあって、for performing many kinds of surgeries。テレメディスンっていうのは、デジタルコンサルティングとか、ペイシェントモニタリングとか、ペイシェントサービス。ホスピタルロボットは、some assisting work in the hospital、デリバリーとか、トランスポーテーションとか、disinfection to reduce the work burden on clinical staff and improve the intra-hospital logistics ということで、ホスピタルロボット is also there。and リハビリテーションロボットは、some assist とか、プロセシックとか、エグゾスケルトンサムシングとか、リハビリテーションは、リハビリテーションロボットですよ。But today we are focusing on the surgical robot ね。surgical operation。ということで、サージカルロボットは、this is also the several surgical robots. It is showing the three applications. First one is arthroplasty. Arthroplasty っていうのは、ジョイントリプレイスメントですね。ジョイントリプレイスメントというのは、some patient is injured. For example, in the elderly people is injured in the knees or hip joint, knee joint and hip joint because of the aging. For so many years, it is used. So therefore, the change its contact surface conditions and also the shape of the contact surface. So therefore, the new artificial material should be put on this. Here is a knee joint, and here is a hip joint. ジョイントっていうのはこのカップとこのカップ側とこのボール側とカップ側。カップパートとボールパートで、in this case, このthese surface, contact surface is damaged or changed its form. So therefore, some new artificial material is put it on in place of this natural bone. This part is replaced in the artificial part. ということで、D ジョイントとかヒップジョイントとかここに書いてますね。それからニューロロジカルサージリーはナーブシステム、especially in the spinal cord とかブレインとかペリフェラルナーブとかエクストラクラニアルセレブラロバスキュラーシステムとかsome related to the nerve systems. This kind of work is done. And endoscopic surgery. Endoscopic surgery is using the endoscopy. In later, I will explain more in detail. ということで、first robot used in the medical field was Robotic. Robotic is used for the knee joint replacement. Knee joint replacement. What? Knee joint replacement ね。Why this kind of robot is necessary? ちょっと to understand this このヒップジョイントリプレイスメントサージリーはヒップジョイントって書いてダメか。 カップがあって、これヒップボーンね。それからここにこういうのあるよね、こうやってね。でここで、ここのボールとここのカップのところでカップね。Some patient is changed its shape, so therefore ここがなんかこうなって it's easy to release. ちょっとこの this part is changed its form, and then it is easy to release. So therefore the cup should be made again. とかね。とか or ball part is become it's smaller and easy to release, of course. とかまあ so therefore some elderly people has this kind of damage because so many years that joint has been used. Yeah? And also after become old, this kind of cushion part is become dry, so therefore the friction force become larger. When the friction force become larger, it is more cutted or 削られる、ドリルっていうわけじゃないな。なんかSo it's deformed. ね。So therefore some replacement work is necessary. To do this kind of replacement, so what doctor will do is for example to replace this bone head, this part is cutted. This part is cutted, and then some hole is made, and then the new material, like this kind of new material this is the artificial material. It's inserted to this bone hole. このボーンにね、このカッテッドリメイニングこのカッテッドパートにthis new material, new tool is inserted to this hole. これがここに書いてあるんですね。この new material is inserted to this hole. So therefore this shape, this hole shape should be matched exactly. When it has some gaps, it makes some cracks and damages this remaining part. So easy to break. So therefore this shape, the same shape should be drilled, should be made hole with this shape as much as possible. But before using the robot arm, this kind of work is done by doctor himself. So therefore, by using some cutter, this bone is cutted. And also by using some tools, it make some holes by hand. So therefore, it is not good enough shape to make. No clearance hole is very difficult to make. Some clearance, some gaps with remain, or too tight. So therefore, it also makes some damage to the remaining part of the bone. So therefore, by using the robot, this hole should be made clearly and precisely. So therefore, firstly, this Robodoc is developed before more than 10 years ago. だからなんか by using the MRI data or some the measurement data, how to make the hole is planned by computer, and then this robot is do some task of the drilling and cutting and drilling this hole. なんか見ますか？ステム、これがステムっていうのね、このブルーパート is called ステム。ステムとこのホールの関係が、ちょっとこれ見ますか？
Start. Okay. So the first point is on the neck.
これブラックすぎるからやめますね。ブラックすぎるからやめますね。これアニメーションだったら大丈夫。This surgical system で、これはなんかこうやって、コンセプトロボットとこのプランニングパートがあって、コンピューターアシステントツールですよと言って、なんですか、how does it work っていうのは、まずは CT スキャンで、なんかデータ should be stored in the computer and 3D model is developed in the computer.And then how to replace this stem is planned. This part and how to make the hole is planned. And then while doing some these surgeons, the surgeons will use this part and marking. Firstly, marking をして、でこのプラントのマッチングをして、でドリリングをしますよ。こっちがロボットトゥールの方ね。ロボットトゥールで to make the hole precisely and then this stem is inserted というやつね。っていうのです。ということでロボドックっていうのは最初にできました。最初にできたのは1986です。私がWhen I was a student, this was developed. で、まあ似たような similar system is already widely used. で、次、next part is neurosurgery で、ちょっとこれはスキップしましょう。ニューロサージカリとかスキップして、次はエンドスコープね。エンドスコープ。エンドスコープって you knows エンドスコープ？エンドスコープっていうのはこのスコープね。ファイバースコープ、firstly it was ファイバースコープで、このところ、このドクター is watching this endoscope lens, and then this part is inserted inside the body through the mouth or through the lower part, and this part here is watching. Firstly it is only watching, and by using the forcepsってこういうフォーセプトでtaking some cells and taking some skins or taking some organisms by taking some part of the inside of the body ね。でこれが end of this endoscope。エンドスコープはエンドスコープこうなってるんだけど、エンドスコープはこうなってエンドスコープこうなってるんだけど、 how many holes there? Endoscope, or end of the endoscope. Basically, how many holes is there? なんかホールがあるよね、これね。で、what kind of hole is necessary to do some task? まあ、カメラね、まあカメラなんだけど、まあ最初はファイバースコープでオプティカルファイバーだったけど、presently it is only lens and the CCD chip ね。これはこのカメラホールが一つね、まあカメラホール。それから and カメラだけで only camera it can watch inside of the body? ライト。Oh, light. Light ね。Light is necessary to watch inside because it's dark part. それからこれも最初はファイバーのライトだったんだけど、まあ、presently some light, electric, some light device is there. それからあと今言ったこれね、フォーセプトっていうなんかカッティングトゥールとかトゥールのためのフォートゥールフォーセプトトゥールフォールそれから何が必要でしょう。もう一つ at least another one is necessary. How to use it? これはトゥールが出てさ、なんかフォーセプトとかこう出てくるよね。フォーセプト。もう一つ at least one hole is necessary. What it is? One channel だ。だからまあチャンネルで。これ What channel is necessary? まあこれチャンネルだ。これもチャンネルだ。トゥール用のフォーセプトのチャンネル。こっちもなんかチャンネルなんだけど何？はい、答えは answer is water or air. Air. The water to washing the inside because some forceps the blood is there and the air is necessary to make the inside of the stomach that it should be enlarged. So therefore the water channel, air channel by using this one channel is necessary. Okay. 水や空気を供給するっていうチャンネルが絶対必要なんだけど、吸引するバキューミングね。はいでした。ということで、まあこういうバルーンとか書いてあるんだけど、まあ、それはいいとして、次にラパロスコピックサージェリーって知ってますか？ You know the ラパロスコピックサージェリー？腹腔鏡手術。ラパロスコピックサージェリー is この次のページのこの図がね、こういうやつです。この図のように、このスタマックのところにホールをいくつかやって、ホールを開けて、このフォーセプトをインサーテッドする this hole。でだから、ベーシカリー、このサージョンズ、both hands to hole と、なんか、これはロボットが持ってるけど、なんかカメラ用のワッチングのためのなんかホールと、at least 3 channel is necessary. 3 holes are necessary to do this. ということで、腹腔鏡手術っていうのは、だから、it is called minimally invasive surgery because only the keyhole surgeon, keyhole perform through the small incision, usually 0.5 or 1.5 centimeter, as opposed to the larger incisions needed to the laboratory. The laboratory is cut by the 10 centimeter or 15 centimeter on the stomach, but by using only the 3 holes is necessary to do this, like this. So therefore the recovery time is shorter. まあここにアドバンテージは reduce hemorrhaging, less pain, but smaller incision. So therefore the leads the faster return to everyday livings, reduce exposure of internal organs to possible external contaminants, thereby reducing risk of acquiring infections. So therefore the only small hole is necessary to do this. But the disadvantage is surgeon has limited range of motion. これ嫌なのは何？これペイシェントがいて、このお腹のところに small hole is there and the forceps is inserted and do some the operations by the surgeon operator. ね、What is これなんかless loss of dexterity とか limited range of motion もちろんなんか inside body, so therefore the movable area is very limited. Poor depth sensation, depth perception is also there. So only watching this camera scope is also inserted. Camera ね。Camera is inserted through another hole. なんだけど、なんか嫌なこと。One disadvantage is if tool wants to move this, but the operator has to move this direction. Because this whole part is fixed. 嫌じゃない。Is it not? You don't want to this? If the two forceps should be move this closer, but the tool part should be released, should be forward. It is no good operation conditions. これ嫌だと思う。ね、これがだからこれ the pivot point ね、こう this pivot point で this operation is moved. For opposite direction, the surgeon must move. It's not good. Some skills or useful training is necessary. ね、ということです。ということで、これはこの this コンピューターモーションの ESOP っていう this robot is developed this camera operation. So this surgeon is using this voice command and the robot moves the appropriate position to put the camera position. っていうやつね。ボイスコマンド。で、no assistance. So usually the assistant, nurse or some assistant is operating this camera by the surgeon's command, surgeon's voice command. But in this case, robot is moved appropriately. ということです。はい。で、ラパロスコピックロボットは、it is the surgical robot. The Vinci system is proposed 1999. It was shown that before starting this class today. This surgeon console is there. The stereo vision is presented to the surgeon, and both hand is operating this operating arm, and the robot has at least 3 arms is there, 2 for the 2 arms and 1 for the vision. で、まあダヴィンチシステムは、まあ firstly the Da Vinci standard and the next one and the third one and presently this Da Vinci Psi surgical system is used. ということで、さっきのビデオはこの this one ね、What is robot surgery というビデオで、ちょっと、プロモーションビデオを見ると、
The Da Vinci surgical system is the most advanced platform for minimally invasive surgery available in the world today. The integration of high-resolution 3D vision, wristed instruments, and intuitive motion control enables the Da Vinci surgeon to transcend the limitations of conventional surgical technologies. 3 network components comprise the Da Vinci surgical system: an ergonomic surgeon's console, a patient-side cart with 4 interactive robotic arms, and a high-definition 3D vision system. Seated at the console, the Da Vinci surgeon views a remarkably clear 3D image of the surgical field. The system scales, filters, and translates the movements of the surgeon's hands on the master controllers to 4 interactive robotic arms on the patient cart. The precisely controlled micro-movements of the Da Vinci instruments are enabled by the computer processors of the system. These dedicated processors perform millions of safety checks over the course of a procedure for enhanced surgical precision and control. Da Vinci EndoWrist instruments are designed with a unique wristed architecture that provides 7 degrees of freedom for a range of motion greater than even the human wrist. This proprietary design enables surgical maneuvers impossible with conventional laparoscopic tools. The system requires that every surgical maneuver is under the direct control of the surgeon. Redundant safety checks prevent autonomous movement of the instruments or the robotic arms. The Da Vinci S surgical system moves surgery forward.
まあいいんだけど、オーディナリー this kind of forceps このフォーセプトね、なんかカッティングトゥールとかなんかハンドリングトゥールね、これどうなってますかっていうと、なんかこういうガンみたいのでなんかこうトゥールがこうあって、あとはこうグリップがあって、なんかこうハンドルがこうついてるっていうようなので、only this handle で only open close motion is made. で this is very thin but hard straight body ね。only straight body and only cut or hang or the close open and so on. Only one movement is made by using this the pistol type the lever ね。But the this robot has the 6 degree of freedom movement. But it only can rotate ね、もちろん rotate and this direction it can move. This direction とか、まあピボットムーブメントでこの this direction can move. Of course, movement and release. ね、ピボットムーブメント。But the このなんだ
With a new level, the Da Vinci S surgical autonomous movement of the instrument.
このインストゥルメントでこれはもちろんクローズ、オープンクローズでしょ、オープンクローズだけど not only open close but also this wrist part can move up, down and right, left movement can realize and of course rotating about that. So therefore it is more easy to operate something, surgical operations. This part is wire drive system is used. ね、このなんかギアとワイヤーがこうあってワイヤードライブでムーブ このワイヤーでムーブ。なんかよくわかんないけど、ワイヤーがこうあってワイヤーがこうあってあると、これがこう動くでしょ。上や下にアップダウンとかするでしょ。ワイヤーがこうドライブなってるんだよと。ね。でこれでワイヤーここがアップダウンするんだよと。このパート、ディスパート。ワイヤーね。だからワイヤーこっちに引いたりこっちに引いたりするんだよ。でこれがこのトゥールパート。トゥールもちろんこれ1 degree of freedom だけじゃなくて、もちろん another direction とか open close part is also the drive by this wire system ね。でだからこっちのパートがこうなりますな。こっちのホルダーパートがこうなんかこう見るとホルダーパートがあって、このパートがあって、で手首があって、このフォーセプトがこういうシステムがなんか
or the robotic arms. The Da Vinci S surgical system moves surgery forward.
これがアタッチされたわけね。ここがストレートのパートで、ここのところはなんかホルダーパートでストレートパートがあって、こっちの側に手首がこう動くんだよっていうね。これこういうアタッチメントパートがこのロボットアームにパキッと作るとアタッチとね、アタッチで、ここのところがなんかこうギアかなんかこう噛み合わせになっていて、このギアそれぞれがワイヤーがこうつながってて、ワイヤーがこうつながってて、ワイヤーがこうつながってて、こっちもこうワイヤーがこうつながって、これワイヤーがこうつながってて、でなんか6 degree of freedom movement can realize。でだからここのところはこのスモールパイプは some wire is going through this part. Wire is moved, and this part is can be released and attached to this arm. Why this kind of system is necessary? だからこうなんかこうボックスになっていて、このボックスがここにくっついてここのオペレーションパートで、それはだからここのなんかアームにロボットアームがなんかこうわかんないな、どうやって書いたらいいのかな。ロボットアームがよくわかんないけど、なんかこうやってアームにこうサポートされていて、なんかここにドッキングしてここにこうつけるんだよとかいうふうになってますね。なんかね、よくわかんないけどこのパートがここにくっついて、ここでこうなりますよと、ね、それがこのサージカルシステムですよと。これがだからこのパートが This part can be released and attached. Why this system is necessary and easy to connect the driving part is connected to だから some driving force is transferred into this system, these tools easily by using this system. ね、Why this system is necessary?
They can make the less pain to the patients.
これもちろんこの This part is inserted into the patient. So therefore,
They are just need 小さいな穴でだけで。
もちろんこう小さい穴だけで、small hole through this small hole, this part is inserted, and this part is largely and moved more widely.
They can reduce the pain of the patients.
Pain of the patient. So therefore, it's only using the small hole and this pivot movement is necessary to operate some surgical operations.
Yes.
But why this part is attached and releasable? Because the patient has suffered of some the virus or some other dangerous conditions. So therefore, this part should prevent some infection.
Yes.
So therefore, the killing the virus operation is necessary once it is used one patient. If we want to use this part to the another patient, before that we have to make the killing virus operation to this. So therefore, this part should be released and attached again. The robot arm is the same, but this part is used again and again. So therefore, it must be easy to kill the virus. So therefore, the attachment system is used.
With a new level of technical capability that enables minimally invasive surgery in complex procedures as never before. Da Vinci provides a streamlined surgical experience that benefits the hospital, the surgeon, the OR team.
もちろん、of course. In some cases, it's only the holding. In some cases, it must be cut. It must be taking some organs. So therefore, the tool must be changed, of course. But another reason is one important reason is to make the killing virus operation easily. もうだから時間がもうほとんどまたなくなりましたね。ということで、このパートと、リーセントモデルはこれでっていうのがあって、それから何を喋りたいかっていうと、この辺か。このキャサリー・モアっていう人はインテリティブ・サージカルのバイスプレゼントとかやってる人で、もちろん、この会社は MIT ベースで MIT のスチューデントからこの、ベンチャービジネスで This company has been made でなんか many movies, videos are there. But recently, the Da Vinci robotic surgery system is make some injury, it is said. So
The investigators are really to be commended for undertaking this. This is a hard thing to do, and it takes a tremendous amount of effort. And the patients are to be commended for trusting their doctors enough to undergo a procedure that's not yet proven to be comparable to the traditional approach. And so this is a big deal. The main finding is that there is no difference between the robotic and open approach in 90-day complications. Importantly, 90-day complications are significant. I mean, it really...
ごめん、これじゃない方がいいや。ちょっと待ってね。これかな。最初の。
Health news now, where robotic surgery is used in all sorts of procedures, including heart and prostate cancer operations. But now the multi-armed robot called the Da Vinci system is under investigation by the FDA because of some safety concerns.
And in response, Intuitive Surgical, the makers of the Da Vinci robot, told Fox 5, and here we quote, Intuitive's highest priority is, and always has been, to provide patient benefit, creating products that in a surgeon's hands are safe, effective, and minimally invasive.
Joining us now is Fox News contributor Dr. David Tsamadi. He is also a robotic prostate cancer surgeon. Good to have you with us
Thank you.
this evening. Okay, so Dr. Tsamadi, there's some big concerns about this robot, particularly the Da Vinci robot. There have actually been reports of deaths and also freak accidents. What is the concern or the problem specifically with the Da Vinci robot?
So this robot, the technology has been around for now 12 years, and hundreds of thousands of these cases have been done. Like any other technology, if you have experienced surgeons plus the technology, you're going to have good results and good outcome. If you have inexperienced surgeons who are not well trained and you give them this technology, you're going to have a bad outcome. I think that's where we are with this.
So you're saying there's nothing wrong with the Da Vinci robot?
There's really nothing wrong with the system itself. I've been personally using it for 12 years. A lot of other surgeons are using it, and I think there is some learning curve, and I think we see more and more surgeons are coming in to use it, but there is a right process and right channel to really get there, and that's the learning curve. And unless you've done at least 200-300 plus, you're not going to do well, and that's why the cases are longer and they may have complications. So it's really up to the patients. When you interview your surgeons, find out how many cases they have done, who performs my surgery. If the surgeon is going from room to room, multiple rooms, and they're not present, that's when you're going to have complications. So there's a lot goes.
So the emphasis here is on the doctor, on the surgeon, here is what you're saying.
Yes, absolutely. This robot doesn't do the operation by itself, Ernie. It's not a
ということで何ですかと言ったら he said だからまあ depending on the surgeon skill まあ personally so therefore まあこれオートノマスロボットサージリー書いてあるけどこれです by robotic surgery there is a risk and also reward of course benefit but some danger is also there so the benefit of course benefit is to provide improved diagnosability and the minimum invasive surgery is targeted, so the decreasing the blood loss and less pain and quicker healing time. So that is very benefit for the patient. The assistive technology, computer control like the naturally occurring heart tremor are filtered. So the surgeon's tremor is filtered by the robot control for him. So it is good. So software technology is reducing the vibrations. And the physician does not need to be in the room and even at the same location as the patient, by reducing the eliminating interoperative infection. So providing a better work environment for the physicians by reducing strain and stress and the fatigue. So because this system is partly developed for the military armies, because the injured soldier is on the battlefield, but the doctors should be more safer locations, so therefore it has been developed. But the consideration, that kind of consideration is necessary. Aims to cut down the medical cost, it's also good. And robotic surgery cuts down the trauma and the healing time. There is money saved in terms of the number of days for the patient to stay in the hospital, and also reduction in the amount of persons needed in the operating room during the surgery. But it is not always true. The extensive training time. So the training time is very important, but it is not defined by some governmental organizations clearly. So in some cases, only 2 hours training patient, trained 2 hours trained surgeons using this kind of robot. So the physician to run the program to operate the machines, it is still very expensive medical robot. So and also the robot itself is very expensive. And the surgeons are so busy, and it is difficult to find some rule to run more and more. There is no national training standard for robotic surgery, so the FDA wants to develop some training program for the robotic surgery presently. And of course, tactile sensing, the tactile sensation, sensory feedback, injury from, so one is injury from hitting adjacent organs. Adjacent organ っていうのは nearby organ is hurted, not intentionally. And also some dangerous is burn from the electrical current. some the まあ electrical current とか it is used so frequently and so the heat is accumulated in the end chip, so therefore this end chip is suffering to the another organ, for example other part is heated, and in some cases it makes some burns. So therefore the more advanced system is also developed in the Da Vinci surgical intuitive surgical company, but this kind no sensory feedback. The hitting another part is a surgeon's mistake, but the electrical current, the heating is the manufacturer's mistake. So this kind of problem is remaining there. っていうのはこれでおしまいかな。これはおしまいですね。That is the end of this today's contents. Okay.